Very good morning. I am Tina Susan Thomas, Assistant Professor IT Department. Welcome you all virtually to KCG College of Technology. We are indeed elated to initiate the first phase of the online short-term program. Over the next few days, we will be dealing exhaustively on the topic, incorporating the techniques of blockchain and artificial intelligence to face the security and privacy challenges of IT infrastructure. Before diving into the learning, let's start with an invocation. I request our third year student, Ms. Claudia Christie, to lead the prayer song.
God will make a way where there seems to be no way. He works in ways we cannot see. He will make a way for me. He will be my guide. Hold me closely to his side. With love and strength for each new day. He will make a way. He will make a way. Oh, God will make a way where there seems to be no way. He works in ways we cannot see. He will make a way for me. He will be my guide. Hold me closely to his side. With love and strength for each new day. He will make a way. He will make a way. By a roadway in the wilderness, he'll lead me. And rivers in the desert will I sing. Heaven and earth will fade, but his word will still remain. And he will do something new today. Our God will make a way where there seems to be no way. He works in ways we cannot see. He will make a way for me. He will be my guide. Hold me closely to his side. With love and strength for each new day. He will make a way. He will make a way. With love and strength for each new day. He will make a way. He will make a way. Thank you.
Thank you, Claudia. Now I request the convener and coordinator of the program, Dr. J. Frank Vijay, HOD IT, to welcome you all to this training program. Sir, please.
Thank you, ma'am. So good morning to my professors, chief guests for the day, associate dean, faculty members, and research scholars. So I take this opportunity to welcome all of you to these wonderful learning sessions of blockchain and artificial intelligence for the next few days. So I welcome our chief guest, Mr. Ravi Venkatramani, CEO, AICTE Premedia, to this STTP. So our guest is indeed honorable, and I am sure you will all enjoy his keynote address. Join hands with me by extending a warm welcome to our chief guest. I welcome you, sir. So I welcome our Associate Dean, Dr. P. Daivasundari, KCG College of Technology, who has extended valuable support for organizing this STTP from the day one. So I welcome you, madam. So I welcome all our participants, research scholars, and the faculty members of KCG College of Technology, and from various states who are actively involved for learning experience. So I like to thank our AICTC for sponsoring this STTP. titled Incorporating the Techniques of Blockchain and AI to Face the Security and Privacy Challenges of IT Infrastructure. So it has been divided into 3 phases. The first phase is focused on industry approach and implementation, which starts from today and it goes up to 5 days up to 28th November. The second phase will be focused based only on research approach. So that will start from 14th December to 19th December. And third phase, it is focused on international practices and experiences from 18th January to 23rd January. So I request all the participants to register for all the three phases to get to know about blockchain and artificial intelligence. And I want to say one thing about this title. So you have seen about the various titles in the 3 phases. So the first phase title has been released to all of you. The title has been framed by expert committee members from various industries. So based on their idea, based on the comments you got from the expert committee members, we have framed the title. And I hope that these titles will be useful for you to gather knowledge about the blockchain and artificial intelligence. So the opening day of our STTP is certainly a moment that we should all be happy. And really, I'm so much excited to see all the participants, the way how you have showed your interest to attend this particular STTP. So the great things happen when there is a gathering of great minds. So it is with great anticipation that once again, I welcome all of you on behalf of the KCG management and principal to this STTP. So hope all of you enjoy our STTP program. Thank you. Over to Tina, ma'am. Thank you, ma'am.
Thank you, sir, for welcoming all the members who represent different institutions and organizations to this training program. Now, I kindly request Associate Dean KCG College of Technology, Dr. P. Devasundari, to give the presidential address and declare the session open. Ma'am, please.
Thank you, Tina. Good morning, Mr. Ravi Venkatramani, our guest of the day. I have heard a lot about you from Mr. Durai, and this is the time I think we are first time meeting virtually. And the speakers who have joined for this inaugural and the participants from across the nation who have joined us today virtually, my dear colleagues and students, a very good morning to all of you. Though this pandemic has put all of us into great concern and many unprecedented situation, if we look at the positive side of it, especially for academicians like us, it has given us not only a focused learning, but also connected the entire world into one single platform. You know, we were not able to get all the industry personnel like this, like Mr. Ravi or all these speakers, just like that for any of the program. Now we know it has become very easy to connect with all of them, not only with the industry people, with academicians across India and also outside country, and many international people. Connect has become a very easiest task because of this unprecedented situation. So, you know, that is on the positive side of whatever we are going through now. But also as this connect happens, it's also important that the privacy and security of this IT infrastructure is taken care of. And I think our IT department has done a very wonderful job by triggering that as the first step to conduct this online short-term training program, which is also sponsored by AICTE and Computer Society of India. They have rightly chosen the topic, you know, incorporating the techniques of blockchain and artificial intelligence to face the security and privacy challenges of IT infrastructure. I'm not getting into the details of any of this blockchain or artificial intelligence. All that I know is these are the two buzzwords of any industry, may it be IT, healthcare, BFSI, manufacturing, e-commerce. Other than that, I'm not an expert to talk about all that, and we sure have many experts across this STTP to give us an idea about all that. And from HOD IT, I also understand that this STTP has been planned in 3 phases. The first one is starting today, which is on the industry approach and implementation. And we could see many of the eminent academicians and practitioners from many reputed industries. The next phase is going to be on research approach, which is going to help all the scholars who are into research to get an idea about how to proceed further. And also the third phase is going to be on international practices and experiences, which has been made possible only because of this situation today that we were able to get many resource person for that too. And across all these 3 STTP, I hope all of you will get valuable inputs And also you all will get ample time to clarify all your doubts on the topic from all the experts. It's also a good connect platform that you get a chance to connect with all of the industry experts here. All the very best to all the participants. My best wishes to the IT department, faculty and students. Have a good session ahead for the next 1 week. Thank you so much.
Thank you, ma'am, for your motivating words. It is indeed my pleasure to introduce today's keynote speaker, Mr. Ravi Venkatramani. Ravi Venkatramani is the co-founder and CEO of AICTE Media Services, and he manages the company's growth strategy. A strong believer in the use of technology to enhance human potential, he has successfully steered product incubation through co-creation with customers. Ravi has worked with several large corporations, advising them on the management, transformation, and delivery of content. At AICTE Media, Ravi has been instrumental in developing Kriya Docs, a document collaboration platform that accelerates publishing. Ravi is a global citizen who has lived in 5 different countries and traveled to many others. He obtained his bachelor's degree in mechanical engineering from the University of Madras and his Master of Science in Engineering from the University of Texas at Austin. He is a member of the Rotary Club of Madras East and enjoys giving back to society through Rotary. We are all eager to hear from you. Over to you, sir.
Thank you so much, Tina. Appreciate that. Let me just share my screen and I'll get started. Are you able to see my screen?
Yes, sir.
Great. Good morning, everyone. It's a pleasure to be here. I think this is a wonderful topic that's been chosen for you guys, and I think you'll find that the amount of learning you're going to be doing over the next 3 months, I guess, is going to be fantastic and something that's very relevant. So what I want to do today before I get started is I want to actually mention my experience with KCG, because I was first introduced to KCG through Mr. Durai. In fact, he invited me to come and judge a Smart India hackathon. And so I had the opportunity to view all the work done by your students, the range of products, the depth in which they got in. And I was blown away by the quality of work that they put together. I saw students who were thinking, who were interested in delving further, and asked lots of very good questions. And it was not just about this checking a box, it was about learning. I think credit goes to the college and to the faculty and everybody behind it to really bring that out into students. So that was my first impression of KCG and the campus as well. It was just, it was mind-blowing. I felt it was a vibrant campus, vibrant students, and so a lot of good things going on because of the faculty and management. Second, I took that a bit further, and we've hired some interns who are now working with us from the third year, or working with us on some very key projects. And again, they've been doing fantastic work. So very thrilled about that. And we're right now in the process of actually interviewing candidates in the final year for our own recruitment. So I'm very excited about who would be joining our company in the coming months. Finally, my last recent association is actually as part of the National Innovation and Startup Policy. There's an implementation committee, and I've been gracefully invited to join that. I'm very excited about that. I think it's my opportunity to play a part in how industry and education can collaborate to make the future a lot better for all of us, for industry as well as all of you students who are part of this program. So suffice it to say, it's an honor to be invited. Thank you, Associate Dean David Sundari, for inviting me. I really appreciate this opportunity, and I'm very happy to be here and to talk to you guys about what I know on blockchain and artificial intelligence. Thank you also, Dr. Frank Vijay, for thinking of me, and thank you, Tina, for the wonderful introduction. So just to, I know Tina talked about what my background is, but I'm just going to quickly talk about two different things. One is I did my MS in Systems and Design at the University of Texas at Austin. So I actually worked on additive technologies. So we had a process called selective laser sintering, and it was all controlled through computers and mirrors, and we used lasers, and we fired a laser at a bed of powder. This was back in 1997 when the technology was just developing and the university had got a patent. So I'm very happy that what we started working on 20 years ago has now started to become more mainstream. And that's something that you should remember is things don't come in overnight. They take several years of people working very hard at it, trying, failing, trying again, and then at some point they succeed, and then they go on to the next challenge. So it's very important to understand the evolution of technology. And the next part is, of course, where I am now. So we, as Tina mentioned, we work on a product called CreaDocs. So CreaDocs is effectively a platform to allow authors to manage their whole publications online. So we have authors who publish books and journals. So they come online, they use our platform, they're able to make all of their necessary changes on that platform. We take their content, which is still in its raw format, we edit it, we typeset it, we finish it up, and then we publish it online to share the content with the rest of the world. So we feel very happy to be part of this because we are sharing groundbreaking research with everybody. And we get to be the ones that say, hey, we made it happen. So it's a very proud feeling that we're a company in India that's working with global publishers. And we have a fantastic platform that's now going even to the next level and becoming a SaaS product. So that's just a little bit about our company. Now, why are we here today? So we are here to talk about AI and blockchain. Now, before we talk about AI and blockchain, it's very interesting to look at what AI and blockchain are also looked at. AI and blockchain are what you would call disruptive technologies. Yes, they're bringing a lot of good to industry, but they're also looked upon as disruptive technology. So people often wonder, is this a bane or a boon? Now, all of us here are obviously part of this AI effort, and so we want it to do well, we want it to grow. But there's a bunch of people who are doubtful or skeptical. Is this a good thing or not? And I think it's helpful when we face the subjections to start thinking about how we got to this particular point and go back in time. And history is a great teacher. So the big question is, AI is disruption. Are we prepared for it? And that's the question I want to take forward today. That's going to be my basis of my talk. So let's talk about the first industrial revolution, which happened in 1765. So the first industrial revolution was all about steam, railroad, and mechanization. So what happened with steam? Yeah, the steamboat was created. And earlier we had only sailing boats. They were using wind speed to go forward, or they had people who were rowing physically. But now the steamboat was created that allowed for transportation of larger ships at higher speed. What this effectively did is it opened up global trade. It meant that ships could now travel from the UK or from Spain or from Portugal and Netherlands, all these countries that were at the forefront of trade, to start now trading with India, trading with China, trading with the Far East, and even going all the way to the US. So these allowed the journey to be cut down quite significantly, which meant that now trade was going a lot faster. The expanse of trade was much, much higher than earlier. Earlier, we only had specific things that people traded. Now they were trading a lot more things. Second thing was the railroad was invented, and it was the revolution in means of transport. This now allowed the people to be connected. It allowed cities to be developed, and it allowed for civilization to start expanding at a rate never before seen in history. And finally, probably the most important one of all three is the creation of the mechanized factory. This now allowed for people to build machines which could create iron bars, could create, at the time, maybe a little bit dated, but creating cloth and things like that. So using machines powered by steam or powered by coal, and instead of a person now using their manual labor to do things, now the machine did all the hard work. The people still had to be there to operate the machine, but it still meant that the power generation was not now human driven. The power generation was done through steam and coal. It's important to understand at this point, when this, when we look back in time, we say, hey, this is a fantastic event. This was a game changer for all of us. But this came with its own disruption. What happened here? All those craftsmen who were part of this, who were making things by hand, and we can think back to the days of the charkha and all of that, they were disrupted. And so this meant that people who had a profession now had to look for other source of work. The good news is I think all of our ancestors found a way to do that. And that's something that I'm going to, again, touch upon at the end of this particular talk, is that change is good. Change happens. It's how we deal with change. And that's what we're going to get to as we go through this talk. So what happened? So that was the first industrial revolution. It lasted about 100 years, and taking us to the second industrial revolution, which happened in 1870. And what was at the forefront of this revolution? It was the discovery of electricity. It was the discovery of oil and the creation of the internal combustion engine, mass production through machines controlling other machines, and finally, methods of communication such as the telegraph and telephone. Now, electricity is absolutely a groundbreaking technology. Electricity allowed you now to use coal and to use your gas to now generate power at much higher wattage that you could now, not only could you generate high power, you could also transmit that power. And there was a big battle between alternating current and direct current, and there was so much that went in because there was that competition that so many advances came in a very short period of time. But electricity allowed you now to run your machines, run your vehicles, run your power plants very differently than was possible before. And then oil was discovered. What does oil lead to? Oil led to the creation of the internal combustion engine. Internal combustion engine allowed now people to move a lot faster. They were not now constrained to waterways or railway tracks. Now they could actually go on the road and go in any direction that they wanted. So they were now set free. So this was obviously a groundbreaking technology as well. And because of the invention of electricity and the discovery of oil, what now allowed is machines could now control other machines. Earlier, you had machines were invented, people were still controlling the machines. But now mass production was possible because machines could control other machines. And that again allowed for cars to be developed. We know all about the Ford Model T and the assembly line and how that was all initiated in this age. So again, something that happened that completely transformed our history. And finally, the methods of communication. So earlier, when we had to communicate, we had to physically go meet people, we had to physically travel and go say what we wanted to say. But now with the invention of telegraph and telephone, people across the world, and I can only say this, our particular signal right now is going all the way to servers, possibly in the US, and coming back to us in India. I think we take this for granted, but all this, the initial steps for all of this was laid back over almost 150 years ago. So it's quite amazing that something small started way back has now led to this great invention of Zoom and other chat platforms that allow us to do what we are doing. Now, what happened because of this? What is the disruption created because of this revolution? Well, the disruption, unfortunately, was that it meant that people now were forced to work in factories. So machines were intended to work with humans, but now with the mass production, now you had to work longer hours. So people had to work harder, longer. Earlier, they just had to work for a short period of time. But now, because of mass production, everybody wanted stuff. And everybody wants stuff, the factories have to run. And for factories to run, you still needed people to do the work that machines could not do. So it just meant a different sort of disruption that happened here. And one thing that happens in all disruptions, as you notice with the Industrial Revolution, is where we started, where mankind started, is with agriculture. So agriculture was probably a game changer for us way back in the time when we were nomadic tribes. We were just going from forest to forest, eating what was found on the trees, eating what was found on the ground, and that's how we operated. So we couldn't really establish a village, establish a family, or do anything like that. And agriculture allowed us to do that. But guess what happened with this Industrial Revolution is that people who were now working on farms now got to work in industries. So people who were working on farms now get to do something that they wanted to move away and go to the cities. So this led to disruption in agriculture. So agriculture initially faced this problem of people not being available. Now, how do I harvest my crop? But it led to the application of the same technology towards agriculture in terms of tractors, in terms of harvesters, and amazing things were invented so long ago. And if you have an opportunity, I would recommend that you go find a video for what is called a combine harvester. A combine harvester is something that was invented almost 100 years ago. It's a machine that's able to harvest corn, it's able to harvest wheat, and it's just able to go down the crop, harvest it on the fly, and then there's a truck going right by the side of it, and it collects the produce. So it's an amazing invention. Yes, that meant that a small farmer could not operate. It meant that farms had to be bigger. But then again, this is what happens with change. You want something, and then you're pushing hard for that. There is some unintended consequences. Yes, unintended consequences happen. But as humankind, we have the ability to adapt. We have the ability to take a challenge and make it different. And it's almost like they say they make lemonade out of lemons. So that's what we are built. We are resilient. We're a resilient race. We're a resilient civilization. We continue to say, hey, every time you give me a challenge, yes, it'll be hard at first, but we'll find a way to overcome. And what was the third industrial revolution? That was again another 100 years later. It was in 1969, and that was the age of electronics, computers, and automation. In some ways, we are part of this age. Either we were born at the beginning of this age or born right in the middle of that 50-year period, but we are very much part of this particular revolution. So what is this revolution all about? It started with the invention of the programmable logic controller. So the programmable logic controller is, as it says, is a chip that you could program that could do things logically. That meant that now a machine could actually go pick up something. A machine could go do a calculation. A machine could do multiple wonderful things. And then as it got miniaturized, it allowed for the creation of computers for the common man. And automation using robots. So earlier you had machines, and machines were still operated by people. But now guess what? Robots could be programmed, and robots would do the same task over and over again, exactly right every single time. And this meant the accuracy went up, it meant your throughput went up, and machines didn't get tired. They would just keep working 24 hours a day, 7 days a week. And finally, the thing that's really unlocking us today is the internet. The ability to unlock global knowledge that was initially stuck in books or initially stuck in people's minds or just in societies. Now the entire knowledge of the world is available to all of us to access. I think one of the big benefits that we're seeing out of COVID, yes, there's been a lot of not so good benefits, but one of the benefits we're seeing is that knowledge is now readily available. We're still able to read up, we're able to educate ourselves, and we're able to access resources which earlier were not necessarily available. The internet has definitely risen to the challenge with all of our countries across the world facing this COVID challenge. All these countries have been gratefully taken care of by these internet service providers who've kept the internet up and made sure all of us have access to bandwidth, access to this data, access to this kind of Zoom meeting, so that we can continue our learning, we can continue our search for knowledge and not be held back. And I think the internet has been that particular of all of them. I think the last one that came in this period that has really transformed our future, transformed our current, and is definitely going to transform our future. But what has got disrupted because of it? A lot of traditional industries have got disrupted, as you can imagine. There used to be a cash register which people use by hand, or a typewriter, or you take robots. So now factories which had a lot of people now don't have to employ as many people. So they've mechanized a lot with robots. And with the internet being where it is, now you don't have to, the time has come where the way we learn is not always in school, it's not always in college. We learn in other ways as well. That does not mean that the school and college is not important. They are definitely showing you how to learn. And that's the real purpose of college and school. Is their job is not to teach you what you need to know. Their job is to teach you how to learn. And I think that's where colleges like KCG do a fantastic job, because they make available conferences like this, where you get to know what's the latest, what's really important. How is this going to affect my future? What do I need to learn about it? And how do I go about that learning? And effectively lay down that path for you, which is, I think, brilliant. And I think, compared to what it used to be in the past, I think KCG has really set the ground running in terms of, hey, let's take advantage of this COVID period. Let's start talking about something that is upcoming. It's not current. It's something that's still somewhat in the future, maybe a couple of years down the pipe. But they're taking the lead in this and making sure that we're all educated, getting prepared, getting ready for that next revolution. And what is that next revolution? It's what is called the cyber-physical revolution. So what do you mean by the cyber-physical revolution? It's really the coming together of the electronic age, electronic world, and the physical world, which means instead of people talking to each other or computers talking to each other, now you have machines talking to each other. Like you have these cars, which are self-driving cars, or you have machines talking to each other through IoT. That is what the cyber-physical revolution is. And a big leader in that is AI, big data, and analytics. So artificial intelligence, which has been around right from the previous revolution even, has now started to get new muscle. And the new muscle has come in because of cloud computing. It's come in because of faster computers, faster internet. And it's just allowed us now to process big amounts of data, large amounts of data, do analytics on it, and then based on those results, do wonderful things with it, which earlier we could not even dream of. Cloud computing, like I mentioned, and now the next phase that's going to be quantum computing, where you're now going to be able to make calculations much, much faster than ever imagined, and effectively bring in the ability to compute big problems in just a matter of a few seconds or even microseconds for that matter. Driverless cars, smart robotics. So earlier you had cars that you had to drive. Now cars can drive themselves. I think all of us have seen ads on TV for the MG Gloucester. They talk about their driverless technology, that if, hey, there's an obstacle coming ahead of you, the car knows how to stop. The car knows how to sense that there's another car in front. And it's basically coming to a point where it's becoming extremely aware. It knows based on data as to when it should speed up, when it should slow down, and all of that. And we know that Tesla has created a car which can drive on its own. You just have to sit behind the wheel and don't do anything. So it's amazing technology that has come out because of this revolution. And of course, smart robotics. Now robots are not just needing to be programmed. They're now able to make some decisions on their own. They're able to, and we see these robots coming through, even in COVID, being able to go serve people, doing various things. So we're just at the beginning of this revolution. And finally, pervasive sensing, actuation, and connectivity. So this really comes down to IoT and these networks which are going to connect IoT. And that's kind of bringing us to why we are here today is now as we start to expand the way we communicate, as we start to have machines talk to machines, as we start to have computers talking to computers, what really becomes important is all the checks and balances that we used to have when we were people dealing with things are now lost. So now, hey, you need to know who's around you. You need to know who you can trust. You need to know how to connect and how to talk to each other in a secure fashion. And that really is what brings in blockchain. And as you do blockchain and you start to work with all this data, which is private at the end of the day, it's either private, your private data or your company's private data. How is that handled? And that is the whole topic of information security. How do you take all this wonderful advancement done by AI, all this great possibility with blockchain, and still make it safe and reliable so that everybody can depend on it and reap the benefits? But what is the disruption going to be from here? Well, I'm going to come to this a little bit later because this is going to be very unique. If you notice all the other disruptions, somebody got affected. Well, this time also, some of us are going to get affected, but who is it? Let's wait and find out. So just to summarize, here's some of the items that are part of the Industry 4.0. We have things like big data, which I talked about. We have augmented reality, virtual reality, additive manufacturing, cloud computing, cybersecurity, the Internet of Things, system integration, where systems are all integrated. You have business process systems controlling everything. Then you have simulations where you have more virtual reality that's happening. Of course, autonomous robots. And if I did one more level of deep dive, let's get into what I would call the physical world meeting the virtual world, meeting the digital world. So what does this mean? Well, we have on the physical world, we know there's 3D printing, we know there's energy, we know there's advanced material. But then now start talking about how that interacts with quantum computing, with smart automation, and with the Internet of Things and autonomous systems, going into the virtual world with blockchain and 6G communication. We're still now getting into 5G, but 6G is very much along the way. And also now getting into, on the digital world and the physical world, getting into nanotechnology. So what's happened because of this revolution is it's now made it happen where we're not just thinking about disruption in terms of us. We're now able to make advances in terms of a macroeconomic way, or rather a macro way in terms of going out to space, doing space exploration, or in a very micro way by going on to the nanometer and being able to look at the cell and seeing how we could invent devices which will make our phones a lot smaller, but also going into fighting oil spills, fighting diseases, and so on. So there's a lot of new development that's happening, all of this. And what's happening with Industry 4.0 is we're now able to connect all of these together, not look at them in isolation. Hey, how can I use advanced materials and then basically look at advanced materials from a nanotechnology perspective? How can I look at my analytics and then based on that, decide how my factory floor should be operated? How can I look at 3D printing and start manufacturing very differently? How can I use the power of quantum computing and based on that, make better decisions for the future of the world in terms of energy utilization, in terms of how we can predict storms and so on. So I think the world is limitless in terms of what potential it offers. So this, I think, is a great way to picture what we're going to be getting into and what your conference is really going to talk about. It's going to talk about a few of these elements, but this is the world you're going to be confronting. A fully connected world, not just in terms of people, not just in terms of machines, but in terms of various areas of our world. So we're talking about AI today, so I thought we should not definitely talk about AI without talking about some things like Alexa or Google Home or the devices like that. And so this guy is trying to talk to Alexa. Guess what? Alexa decides to be intelligent, and Alexa says, "Hey, you're a lazy bum. You can't even load the dishwasher correctly." And this lady says, "Hey, you're looks like it's doing machine learning as well." So yeah, machines are getting smarter and smarter every day to the point that you wonder if machines are going to tell us what to do. And if that happens, who's the arbiter of that? How do we control that? It's an interesting question. I think there's different schools of thought on that. There's people who say, hey, no, machines will not be able to get to that. They won't become sentient. But then there's another school of thought that says they will. But again, that's a debate for another day. I just thought it was an interesting cartoon to start off the session. So artificial intelligence is not new. Artificial intelligence existed since the 1950s. And are AI, ML, and deep learning different things? Not really. AI encompasses machine learning, and machine learning encompasses deep learning. So AI was first invented to do simple things like play a game of chess, or play a game of checkers, and so on. And it was just based on the machine reacting to the problem. And that's what was possible for most of the 50s, 60s, 70s, is that's all AI could do, because compute power was not that good. Chips were still very large, computers were still very big, and so you couldn't really do much. I mean, buying a computer was very expensive. So then, as computers started to get miniaturized, as chipsets started to develop, then it brought the advent of smaller machines, smaller servers, smaller computers, and now gave us the ability to do what is called machine learning. Machine learning is effectively a machine. You give it a set of instructions, tell it what to expect, tell it how to make a decision, and it then learns that and starts doing that on its own. And so effectively it's trying to mimic a human being at that point. Deep learning is the next step where, yeah, I know how to learn from something that you tell me, but now how about I learn how to do things also myself? And that I can just look at data on my own rather than a human being telling me what to do. I can go study data, get my own insights from the data, and then start to make decisions based on that data. So I found a very nice slide that talks about how this works. So we have an input, like say a car, and I want to identify a car. So this person, who's a data scientist, tries and puts in some features about the car, that this car will have 4 wheels, this car will have 2 doors, this car will have the engine at the back, will have a boot in front, this is a Beetle, and then so on. And based on that, we'll train the system to recognize what a Beetle is, recognize what a Hyundai is, recognize what a Maruti is, and so on. And then the classification happens, and then it tells you it's a car or not a car, or it's a Beetle or a Honda or a Toyota, and so on. The deep learning is the next step where now I don't even have the person having to come and tell me that. I'm just able to look at that data, make my own inference about that data, and take that to the next level. It's using neural networks. Neural networks are effectively networks that start to mimic the human brain. They're able to start thinking like a human brain would, and then start to make decisions like that. Again, it's still very rudimentary in the way they're operating. We have various types of neural networks, but the way the research is right now, it's still very rudimentary. Again, over here, we're still scratching the surface because I think people still don't know how the neural network actually works. They're like, hey, the machine's coming up with this answer, but I don't know how it came up with it. And they're still scratching their heads to how that's happening. And this is, I think, this is the debate that we need to actually get to the point of understanding this, because if we don't, then this leads to that runaway world we're talking about, where machines could start thinking for themselves and start telling us what to do. So I'm here today as a CEO of Exeter, and I'm talking about AI. So I wanted to give you a brief view of how we use AI. So CreaDocs is our flagship platform. CreaDocs is a on-the-cloud platform that automates the publishing lifecycle. And what CreaDocs is able to do is takes that author's manuscript, does a whole bunch of different things on it. It does a check of the language of the author, of the author's manuscript using natural language processing, make sure that the language is sufficient, it's got good grammar, it's got good, it doesn't have any spelling errors, and it's following good scientific writing or good, basically academic writing style. And then goes one step further and says, okay, hey, can I generate an abstract of that particular article so that it covers all aspects of that particular article or that particular chapter, and makes that available. So now the author can go look at that and then finish it up, rather than having to go do this as another step. And another important thing is called summarization. And so summarization is very important because we're all dealing now with increasingly complex topics. And the way evolution works is, let's say you're learning AI today. You had to learn computers, you had to learn programming, you had to learn various things before coming to that point. Now, imagine now a layperson wants to learn about AI. How do they learn it? Well, you need devices that can now generate what is called a layman summary. A layman summary means a common man summary of that particular article, because we want all these developments to be understood by people. Yes, they won't understand the intricacies of it, but they need to understand enough to know how it affects their life. And so there's a big push now to have layman summaries for all these journal articles, and that is done in our system using machine learning. On the content, we currently have people editing content, because we still believe that content is being written for people, which means that the editing should be done by people. But at the same time, there's a huge opportunity for us to look at how we can edit the content using automated techniques like NLP and ML, so that the content can be finished up, made really, really good and acceptable, and make the author look really good. We do quality control using rule engines. So these are a bunch of rules that are able to go look at what the publisher's guidelines are, make sure that this particular content is meeting those standards. And finally, typeset proof generation using ML and deep learning. So when you see a book or when you see a journal article, it comes in a certain format, it's presented very nice. You have columns of text, you have figures, you have tables, you have equations. They're all presented very nicely. So all this is now completely automated, and we use a bunch of machine learning and deep learning techniques to generate this. And effectively what happened is we allowed the authors to drive the entire publication process. See, what happened initially when authors started writing is there were a bunch of people at publishers who were doing this work for them, and authors were kind of separated from the process. They just had to give their manuscript, and somebody else did all of this and just said, okay, it's done. But now authors have a lot more control. And when authors have more control, it's their life's work or their research, and they get to control how it comes out. Yes, publishers will still define the rules, but authors have a lot more control, and they're happy to do that. So that's what Exeter does with AI. But in terms of, if you want to use AI, how do you get the best out of AI? Well, you use mixed role teams for every AI project, which means you have a data scientist and you have a programmer and a project manager, and make sure you have all of these different people, because it's not just about solving a technical problem. It's about solving the problem for a business user and solving the problem within the business constraint. And so it's very important to have multiple people in your team. And you also need to look at how you can expand your roles to get a 360 view, which means, hey, can I get a user interface consultant? Can I get a customer to join my team, so that when I'm building something for them, that they're also part of this, they're also contributing, and this means that the final outcome is a lot better. Involve your top executives in strategy and funding. So don't go about doing your own project on the side and then find out, hey, that nobody's willing to support you. I think everybody wants to support, but nobody wants to be blindsided. So the best way to do that is to involve your management, involve your higher ups in the process, so that they can understand the strategy, believe in it, sponsor it, and give you the money to support it. Do AI with a purpose. So have a certain purpose for AI. Don't just do it because, hey, I also want to be an AI company. It's very important to have a clear goal of where is AI useful, where is it a good application. Do it and measure it. Make sure you get the results. Don't just do it, we did it, we're not getting results, but it's okay. It's not okay. I think it's very important that any task we take, we do get the necessary outcome, and you do have to do that with measurement. And finally, limit the number of proof of concepts. It's very easy to get carried away with AI, go do a bunch of different projects, and then find that you haven't really moved. And I think it's very important to say, I'm only going to do a few projects, make sure I get the results, take that learning, and then apply towards the next set of initiatives. And so I think this is somewhere that people can be a bit more careful in how they take on AI. In terms of myths about AI, I'm going to quickly run through this. I think most of you know this. AI is not expensive anymore. You can get on Google Colab and run your own AI process, do your own learning, and get the results really quick before you make any big investments. So it's now available to any company to use. Intelligent machines are now able to learn on their own. Is that really true? Not true, because you need somebody who's going to be able to guide the machine, make sure that it identifies, he or she identifies false positives, and guides that machine appropriately. Because if you feed the machine false data, you're going to get bad results. So it's very important to guide that whole process, curate that process. AI is free from bias. What does bias mean? Bias means making judgments based on either race or gender or location and so on. And it's very important that the decisions or the suggestions made by AI are free from bias, because what will then happen is something that will work in the US will not work here or something, because that's what's happened with image processing, is that it has been fed data from people with fair skin. And now when people with darker skin comes in, it's not doing such a good job. It's because that bias was introduced in the system based on the pictures that they fed it, and the system has learned. But now it cannot unlearn easily. Now you have to start all over again. So this is something that they've encountered, especially in image processing, that's a stumbling block. So it's very important to make sure AI is free from bias. And finally, the classical thing, AI will only replace mundane jobs. The truth of the matter is, AI is going to replace a lot more jobs than we think. I think AI could potentially write code. I think AI could write its own algorithms. So this is all possible within the realm of imagination. So I think these are all things that we will encounter as we go forward. And I was talking about change, and we'll get to that. But keep that in mind when I said AI is going to do a lot more than do mundane jobs. And just a quick slide about blockchain. Blockchain, a lot of people I talk to blockchain, there's some cases like in the financial system where blockchain could change everything. Blockchain could replace the role of banks. You won't need a bank. If people can trust each other, there's no need for a third party like a bank to be the trust party in between. It will change everything. But in most other places, people are trying to say, I want to do something with blockchain, and I want to see what we can do. But honestly, blockchain is a very specific technology. It's in a environment where you have very low trust. When you have a low trust environment, that's why you use blockchain. So blockchain is not appropriate for all areas. Again, this is changing as we talk about it. But one of the classic statements that I heard is blockchain is a solution looking for a problem. It's a solution that's looking for a problem. So we're still trying to identify what is the great applications of blockchain. Just a quick slide to give you a primer as to what is a blockchain. Effectively, someone requests a transaction. The transaction is broadcast to a peer-to-peer network with computers called nodes. These networks then validate that transaction and the user status using known algorithms. Once that validation has happened, then it gets added to a immutable ledger, where this is added as a new block to that ledger. There's no way to break that chain. It becomes permanent and unalterable. And there your transaction is complete. And we all know about cryptocurrency like Bitcoin and Ethereum and Coin and so on. There's multiple such Bitcoin, and I think you guys will learn a lot about the different types of blockchain systems that are available now. This is how it works. So supply is not determined by a bank. It's completely decentralized. But I'm now going to talk about the pros and cons of blockchain. I think this whole seminar will talk a lot about that. But we will go into what Gartner predicts are the top tech trends for the coming years. So the first thing that they're predicting is something called hyper automation. And this means combining robotic process automation, business process management systems, and AI, and expanding what automation can be done today. So rather than look at, I've automated this particular process, automate that particular process. Now, how can these processes talk together and expand how not only am I automating small processes, now they're all talking to each other and now potentially automating a whole company. And they're saying that potentially hyper automation will lead to basically a replica of your company in the digital world, which is very interesting to even imagine. The second trend that is predicted is multi-experience, which means multiple touch points and experiences using artificial reality and virtual reality. Democratization of tech. So tech is now available to the smallest company, to the smallest individual. We're all able to learn about these new techniques, apply it, do various prototypes, build products. And I think the world of SaaS is case in point. Now, not only can any company build a product and make it available to the world, now also a small company does not need to go to SAP to buy software. They can buy software on a rental basis, on a monthly basis. So everybody has access to various technology, and COVID has been proof of that. Is even though we've all been down, we now all have access to Zoom at a very inexpensive rate, and we're all able to still communicate and collaborate and learn. Human augmentation, which means enhancing cognitive and physical experience. So part of this is about enhancing the ability of the brain to think and process, and also for people who are handicapped, enhancing their ability to be able to move and take care of themselves. And there's a lot of applications in that particular area. Transparency and traceability. So people are now not only interested in, hey, you're taking my data. I want to know who's taking my data. I want to know how it is being stored, and I want to know how it is being consumed. So I want to see that whole process. And this is particularly helpful in terms of an election. They're saying in an election, I want to know that my vote was registered. I want to know that my vote went for that particular person. and I want to know how that vote impacted their end result. That's the kind of traceability people are looking for in the future. Then we have the empowered edge with IoT. Effectively, it's about machines talking to each other, the information processing, the content collection, and the delivery integrated with source, which means that machines can talk to machines. They have a way to talk to each other, share information, and then process things along, rather than somebody to collect the information, send it off somewhere, work offline, and then do that. So now it's empowered. The distributed cloud with the benefits of the public cloud married with the benefits of a private cloud. Autonomous things, vehicles, robots, appliances. A practical blockchain, which is traceable, immutable, a distributed ledger, but with a public consensus mechanism. Right now, blockchain is not scalable because the way it's set up, it's not set up for mass public adoption. I think you guys will be talking about some of the new developments that are happening in this area. So I'm very interested in looking at this space. And finally, AI security. So protecting AI-powered systems and data and using ML to predict any attacks that will be forthcoming. So it's very important now that you have these AI-powered systems and data. These are all basically proprietary information, private information about you or your company. It's very important to protect that data. And then how can you then use ML to start predicting, okay, where are my attacks going to come? How are people going to try and manipulate this data or steal my data? And based on that, put in safeguards around it. Okay, so that's AI, ML, blockchain. So that's my primer. I was asked to do that today, but I want to leave you guys with one thing. Is this revolution, unlike the previous revolution, so if you take the first revolution, the second and third revolution, the people who were part of disruption, who were making the disruption happen, were not the ones disrupted. This 4.0 revolution is going to be quite a bit different. We are going to be disrupting ourselves. If computers can start writing their own code, if they can start being the arbiter of information, if they can start talking to each other, they are going to also change the way we operate. I don't want to say they're going to take away our jobs, but they are going to change the way we operate. So we are actively working to disrupt ourselves. That is the amazing part of the 4.0 revolution. It's not something to be scared of, it's something to be aware of. And then realize that now you're going to have to change before you're forced to. Because earlier, you were making the change, but you were not the one who was forced to change. Guess what's happening now? You are going to be forced to change. And so it's important to be ready. So that's the why. And how do we go about it? Well, do realize that society is changing. And like I said, Industry 4.0 will disrupt us all. The important thing to note here is when we have discomfort, when you have annoyance, when you have frustration, that's when growth happens. When you start to be pushed to a corner, that's when growth happens. That's what's happened with COVID. Just this morning, I had a haircut, and I had somebody from Urban Clap come home and give me a haircut because I'm not comfortable going to a shop. What has happened is because of technology, now the guy who otherwise would not have employment is able to be employed, is able to come give me a professional service and get things done. So growth will happen. So challenges are going to be faced, and we as a race will find solutions to those challenges. And that's what we need to remember, is growth always happens at the edge of discomfort. So what can we do? We can read, we can imbibe and share our experiences. And this is very critical. You are all going through lots of different classes, different trainings, and you're learning lots of different pieces of information. I think it's very important to read, to learn, and not only to learn is to share, because I think collectively we can learn, and as we share, we will learn it even better, and we will fast track this whole learning that we want to do, fast track this whole development that's upcoming, is by us collaborating. I think your Associate Dean said it really well about what this revolution COVID is doing is it's connecting us across the world. It's bringing together people who otherwise would not have had the time or the ability to come and participate in such a great event. And I think it's allowing us to now share and learn a lot faster and grow as a benefit of that. So what we need to do is challenge ourselves to learn new skills. Start every day, do a small part of it. And there's a concept called tiny habits. So make it easy, learn one little thing every day and start building on top of it. Because any challenge can be overcome, but it's very important to start small. And so what you need to do is challenge yourself to learn new skills. And finally, be the change you wish to see in the world. This is a quote by Mahatma Gandhi. I think Gandhi was a testament to that. He imagined an India which was going to be independent. Nobody else could see it. He saw it. And he worked hard at it. Everybody else was doubting him, but he said, I'm just going to stick to my method. I'm just going to keep going after it because I see this vision. And no matter what obstacles I see, I'm not going to see that. I'm going to focus on my goal. So as long as you guys focus on your goal and you focus on the change that you want to bring in, you will absolutely be successful and all of us will benefit because of it. Thank you all.
Indeed, it was an informative session and we are all indebted to Ravi Venkatraman sir for his insights. Now, participants, if you have any queries, you can ask. You can either use the chat box or you can unmute and speak. Sir, just a question.
Yeah.
For what was steam engine to industrial revolution, AI is to the cyber physical revolution. In that context, can you deliberate specifically upon what AI can do take us out from the pandemic?
Well, I think, yeah, it's a very good question. AI taking us out of the pandemic. I think what's happened is because of the ability of computers now to process data, all of these trials that people are doing on the vaccine, they're all being accelerated quite significantly. They'll also be able to do contact tracing, to be able to limit the particular infection to a particular area and trap it before it becomes widespread. So we're already seeing how AI is helping from that perspective. But something else that's happening is now countries are sharing data. They're all doing these calculations across various geographies, various companies, and all of that. But they're sharing data, and the sharing of data is helping tremendously because instead of you having to employ millions of computers to do it, now that work is spread across the world. I think that's been the biggest benefit of AI in this pandemic.
Okay, sir. Thank you so much. Participants, if you have any more queries, you can ask. Okay, thank you all. To conclude the session, I find it to be my pleasure to address you people with a word of thanks and gratitude. First of all, I would like to thank Associate Dean Madam for enlightening with her words and formally inaugurating the STTP. She is indeed a source of motivation for all of us here at KCG College of Technology. I would also like to thank our HOD, who is the brain behind the whole STTP. I thank him for welcoming us all to this program and being a constant life force power of the IT department. Now, to the kingpin man in the room, for the entire session, we are thankful to Mr. Ravi Venkatramani for his valuable insights and helping us understand more about the fundamentals of artificial intelligence. We are thankful to you, sir. On behalf of the STTP team and KCG College of Technology, I thank you taking time out of your busy schedule and laying the foundation for AI and setting the ball rolling for the STTP. I also thank all of you participants to be good listeners and being active participants across the session. Before closing the session, I would like to have the attention of the participants. Please note that all the participants should attend all the sessions and you need to fill the feedback form for all the sessions. This is essential as your certificates are generated on basis of that. For every single session, we have arranged respective experts in the field and all the sessions would be equally beneficial to all of you. Our only request is to be punctual and maintain the time according to the schedule. Thank you all. Seeing in the next session.